We're going to look now at how a perfectly competitive firm decides to maximize profits, or more specifically, how they figure out what quantity they should produce so that they can maximize profits. Now, we have seen already that a perfect competitor's demand curve will be a perfectly horizontal line at the market price. Okay, and we label that a lowercase d to indicate it's the firm demand curve. If we think about what that means for their marginal revenue, the amount of money they're going to earn for each unit they sell, let's say that this is, or we'll just make this a $2 price to keep things simple. And so that means that when they sell one product, they make $2. When they sell a second product, they get another $2. A third product, they get another $2. Every time they sell another unit, the additional revenue they earn is exactly the same as the price. Okay. With a downward sloping demand curve, if you were going to sell another unit, you're actually having to lower the price. And so you are earning the additional revenue from selling one more unit, but we're going to assume that there is one market price, and if the only way you can sell one more unit is to lower the price, you're lowering that price on all the other units that you're selling. We'll see that a little bit more in detail when we get to monopolist competition, oligopoly, monopoly. But one thing we can see very easily with the perfect competitor is that every time they sell a unit, they get exactly $2 on the next unit. They sold the previous unit at $2. Every unit they sell at $2. And so the upshot of all of this is that their marginal revenue is in fact the same thing as the market price. So we can see, you'll see this sort of labeling in a lot of perfect competition graphs, where you have your demand curve, the firm demand curve, is equal to marginal revenue, and it's equal to the price. This price equals marginal revenue is one of the characteristics of perfect competition. All right, so if they're going to earn $2 every time they sell a unit, they're going to have total revenue of $2 when they sell one unit, total revenue of $4 when they sell two, total revenue of $6 when they sell three. So every time they sell a unit, for every quantity, every unit they sell, they're going to earn exactly $2. And so graphically, your total revenue would look something like this. And the slope of your total revenue is $2. So sell one unit, go up $2. Sell a unit, go up $2. Sell a unit, go up $2. And so the slope of the total revenue curve is exactly $2. It's a flat or straight, I should say, constant slope curve, because the slope of the total revenue is the marginal revenue curve. Okay. What is the cost curve? We're just going to draw what would look like a typical cost curve for a firm. As you've learned, there is a thing called fixed costs, that normally firms have some amount of fixed cost when they are producing absolutely zero. So the total cost curve would start at some positive amount of dollars there. And then a very typical shape of a total cost curve is something along these lines here. All right, so what do we do to figure out how a firm will profit maximize? Well, first of all, profit, and you often see this little symbol like that for profit, is simply the difference between all the money you take in, which is total revenue, minus all the money that it cost you to make it. So total revenue minus total costs. So where this is the biggest number possible, where total revenue and total cost are the farthest apart, that will result in a subtraction where the profit is the highest. So where are they the farthest apart? Well, they're pretty far apart over in this area, but this is not such a positive area for the firm, because if you notice, their total cost is higher than the total revenue, so they are losing money here. And just because they get to this point here doesn't mean that they are at break even. They have this accumulated amount of cost above their revenue. This is an accumulation of a loss, even when they get here. What's significant about this point is at least now the revenue is higher than the total cost. And so if this is an accumulated area where they're losing money, this is an accumulation of where they are earning more than they are costing. And at some point, you're going to get to where this profit is maximized, where total revenue is as high as it's going to get or as far as it's going to get graphically from total cost. So look here, we're fairly close total revenue to total cost here and farther here, and then we start getting closer again. So where they're going to be the furthest apart is going to be somewhere in this area here. And mathematically what it means is, remember the slope of total revenue is marginal revenue. Well, guess what the slope of total cost is? It's marginal cost. All right, why is that? Well, marginal cost is capturing the additional cost of the last unit, okay? And so here we see the marginal cost is fairly a small number. It's going to be something less than the 2. Remember, this is the slope of 2. And as the total cost curve curves up, the slope, the additional cost of the last unit is increasing as well. So up here, the total cost, the marginal cost of this last unit is probably more like $4. So going from somewhere around $1 to $4 is how we see this total cost curve changing. And at some point, the additional cost will be exactly equal to 2, and that will be where these two are the farthest apart. Now we can see this down below if I draw in the marginal cost curve, and it would look something like this. We see then that we have marginal cost falling at first, kind of capturing this part here, and then it begins to rise, capturing that part there. And wherever these two are equal should be approximately, I'm going to have to kind of cheat a little bit here, where these two are equal. So where these curves up here, the total curves, have the exact same slope is where marginal revenue gives marginal cost. And that is going to be the profit maximizing point. So total revenue equals, profit equals total revenue minus total cost, and profit is maximized where marginal revenue equals marginal cost. That's where we maximize total revenue minus total cost. Now, let me show you one more thing. One way to understand why this is a significant point is, as we look down on this graph here, if we're in the low unit area, we haven't produced very many yet, low quantity area of production. For this unit, I have an additional cost of, say, 75 cents for that particular unit, and I have an additional revenue of $2. So I'm earning $2 at an additional cost of 75 cents. I'm making $1.25 on that unit. I can do that all day long, as they say. And so I can continue to, I produce the next unit, maybe it's 80 cents additional cost in order to earn $2. Then it's 90 cents to earn $2, $1 to earn $2, $1.25 to earn $2, $1.50 to earn $2. And finally on this unit here, I'm earning $2 at an additional cost of $2. And so I want to make every unit up to that point because my revenue is growing faster than my cost. This here is going up faster than this is. And so this distance between the two is growing and growing and growing. My profit is growing all the way up to this point. But if I were to make the next unit, my additional cost to make that next unit might be $2.10 in order to earn $2. So would you pay someone $2 so that you could earn, wait, I think I said that wrong. Would you pay somebody $2.10 so that you could earn $2? And I'm pretty sure you'd say no to that because you're losing 10 cents at that point. And so what's happening is not that you're instantly losing money overall. You could still be making a positive profit, but what you're doing is you're now growing total costs faster than total revenue. And so you're beginning to shrink the profit. And so that is why this is a significant profit maximizing point. This here is the quantity you will be making to maximize profits.